The human body is a remarkable machine, capable of incredible feats of strength and endurance. Central to this physical prowess is the muscular system, a complex network of over 600 muscles that constitutes a significant portion of our body weight. These muscles, working in concert with connective tissues, provide the power and control necessary for every movement we make, from the most delicate gestures to the most strenuous physical tasks. Muscles are the engine of our physicality, the driving force behind our ability to walk, run, jump, lift, and interact with the world around us. Their importance extends far beyond mere movement. They play a vital role in maintaining posture, stabilizing joints, and even regulating body temperature. Understanding how muscles function and adapt is key to unlocking their full potential. Whether you're an athlete striving for peak performance or simply looking to improve your overall health and fitness, the principles of muscle growth apply to everyone. This essay will delve into the fascinating science behind muscle growth, exploring the mechanisms by which these remarkable tissues adapt and strengthen in response to the demands placed upon them. Muscle function is a symphony of coordinated contractions orchestrated by the nervous system. The brain, acting as the conductor, sends signals through motor neurons to individual muscle fibers, instructing them to contract or relax. These contractions generate the force required to move our bones and execute a wide range of movements. Imagine reaching for a glass of water. Your brain sends signals to the muscles in your arm, causing them to contract in a specific sequence. Biceps contract to bend your elbow, triceps relax to allow the movement, and forearm muscles adjust your grip. This intricate interplay of muscle contractions, both large and small, enables us to perform even the simplest of actions with precision and control. But how do muscles generate this force? The answer lies within the structure of muscle fibers themselves. Each fiber is composed of smaller units called myofibrils, which contain contractile proteins called actin and myosin. When a muscle receives a signal from the nervous system, these proteins interact, sliding past one another in a ratchet-like mechanism that shortens the muscle fiber, producing force. This process, known as the sliding filament theory, is the fundamental basis of muscle contraction. It is the engine that drives our movements, the powerhouse of our physical capabilities. The human body is remarkably adaptable. When subjected to physical stress, particularly resistance training, our muscles undergo a process of adaptation and growth. This phenomenon, known as muscle hypertrophy, is the key to increasing strength, power, and muscle size. Imagine attempting to lift a heavy weight for the first time. Your muscles struggle to generate enough force, and you may find yourself unable to complete the lift. However, with repeated exposure to this challenging stimulus, your muscles begin to adapt. The nervous system becomes more efficient at recruiting muscle fibers, optimizing the firing patterns of motor units to produce greater force. This improved neuromuscular coordination is one of the initial adaptations to resistance training, allowing you to lift heavier weights and perform more repetitions over time. But the adaptations don't stop there. As you continue to challenge your muscles, they respond by increasing in size, a process driven by a fascinating interplay of cellular and molecular events. The process of muscle growth is initiated by microscopic damage to muscle fibers during strenuous exercise, particularly resistance training. This may seem counterintuitive, but these tiny tears within the muscle tissue are a necessary catalyst for growth. When muscle fibers are damaged, they release inflammatory molecules called cytokines. These signaling molecules alert the body to the injury, triggering an inflammatory response that is essential for repair and growth. Immune cells rush to the damaged area, clearing cellular debris and initiating the rebuilding process. Satellite cells, specialized stem cells located within muscle tissue, are activated during this repair phase. They proliferate and differentiate, fusing with existing muscle fibers to donate their nuclei and contribute to muscle protein synthesis. This process, driven by an intricate network of signaling pathways and growth factors, leads to the repair of damaged muscle tissue and the addition of new muscle proteins, ultimately resulting in increased muscle fiber size. Section 5. The Overload Principle, Pushing Your Limits. Central to the process of muscle growth is the principle of progressive overload. This fundamental principle of exercise science states that in order to stimulate muscle growth, You must consistently challenge your muscles with workloads that exceed what they are accustomed to. Imagine lifting the same weight for the same number of repetitions week after week. While this may maintain your current muscle mass, it won't lead to significant growth. Your muscles are incredibly adaptable, and they quickly become accustomed to a given workload. To continue stimulating growth, you must progressively increase the demands placed upon them. This can be achieved through a variety of methods, including increasing weight. Gradually increase the weight you lift for a given exercise. Increasing repetitions. Perform more repetitions with a given weight. Decreasing rest periods. Shorten the rest intervals between sets, forcing your muscles to work harder in a shorter amount of time. Adding new exercises. Introduce new exercises that challenge your muscles in different ways. The key is to constantly push your limits, stepping outside of your comfort zone to provide your muscles with a stimulus that signals a need for adaptation and growth. Section 6. Fueling the machine nutrition for muscle growth. While exercise provides the spark for muscle growth, proper nutrition is the fuel that powers the process. Building muscle requires raw materials, and these materials come from the food we eat. Protein, in particular, is crucial for muscle growth. Protein is made up of amino acids, the building blocks of muscle tissue. When you consume protein, your body breaks it down into these amino acids, which are then used to repair damaged muscle fibers and build new ones. The amount of protein you need for optimal muscle growth varies depending on factors such as your training intensity, body weight, and overall calorie intake. However, as a general guideline, aim to consume around 1 gram of protein per pound of body weight per day. In addition to protein, carbohydrates and fats also play important roles in muscle growth. Carbohydrates provide energy for your workouts and replenish muscle glycogen stores which are depleted during exercise. Fats are important for hormone production and overall health. Section 7. Hormonal harmony, testosterone, IGF-1, and growth. Hormones act as chemical messengers within the body, regulating a wide range of physiological processes including muscle growth. Two hormones in particular, testosterone and insulin-like growth factor 1, or IGF-1, play pivotal roles in muscle protein synthesis and hypertrophy. Testosterone, often referred to as the male hormone, is produced in higher amounts in men than in women. It promotes muscle protein synthesis, increases satellite cell activity, and creates an anabolic environment conducive to muscle growth. While women also produce testosterone, their levels are significantly lower. IGF-1, as its name suggests, is structurally similar to insulin and plays a crucial role in growth and development. It is produced primarily in the liver in response to growth hormone stimulation and exerts potent anabolic effects on muscle tissue, promoting protein synthesis and satellite cell proliferation. Resistance training, particularly heavy compound exercises, stimulates the release of both testosterone and IGF-1, creating an optimal hormonal milieu for muscle growth. Section 8. Rest and recovery, rebuilding for greater strength. While the physical act of working out initiates the muscle growth process, it is during the rest and recovery period that the real magic happens. When you subject your muscles to strenuous exercise, you are essentially breaking them down. It is during the hours and days following your workout that your body repairs this damage, rebuilding muscle fibers stronger and more resilient than before. During rest, your body ramps up protein synthesis, using the amino acids from your diet to repair damaged muscle fibers and build new ones. This process is energy-intensive, requiring adequate sleep, nutrition, and overall recovery to occur optimally. Adequate sleep is crucial for muscle growth, as this is when the body releases growth hormone and other anabolic hormones that promote tissue repair and regeneration. Aim for 7 to 9 hours of quality sleep each night to support muscle growth and recovery. Section 9. The growth cycle. Challenge, tear, eat right, repeat. The process of muscle growth can be summarized in a simple yet powerful mantra. Challenge, tear, eat right, repeat. This encapsulates the essential elements of muscle hypertrophy, highlighting the cyclical nature of breaking down and rebuilding muscle tissue. Challenge. You must consistently challenge your muscles with workloads that exceed what they are accustomed to, forcing them to adapt and grow. This is the principle of progressive overload in action. Tear resistance training, particularly heavy lifting, causes microscopic tears within muscle fibers. This damage, while seemingly counterintuitive, is a necessary catalyst for growth. Eat right. Proper nutrition, particularly adequate protein intake, provides the building blocks for muscle repair and growth. Fuel your body with the nutrients it needs to recover and rebuild. Repeat, muscle growth is an ongoing process. Consistency is key. By consistently challenging your muscles, providing them with proper nutrition, and allowing for adequate rest, you create a positive cycle of adaptation and growth.